Imagine looking at the night sky and seeing a dark, unremarkable object, a star that doesn't seem to do much of anything at all. No brilliant shine like the sun, no intense radiance, no energy that you can feel. Instead, it's just there. Yet, this seemingly failed star could be hiding one of the most profound mysteries of the universe. And, incredibly, a new tool, NASA's James Webb Space Telescope, has begun to peel back the layers of that mystery, revealing something far more surprising than anyone could have imagined. The James Webb Space Telescope, JWST, is, by far, the most powerful observatory ever sent into space. It's equipped with state-of-the-art instruments that allow it to peer into regions of the universe that were once completely invisible to us. The JWST's most impressive feature, perhaps, is its ability to detect infrared light, a form of radiation that's invisible to our human eyes. This capability opens up an entirely new realm of cosmic discovery, allowing us to see faint and distant objects that would otherwise be obscured by the vastness of space. One of the most startling findings from the JWST so far concerns a class of celestial bodies known as brown dwarfs. These enigmatic objects have long been referred to as failed stars, but this term only begins to scratch the surface of their complexity. Brown dwarfs are intriguing because they occupy a strange and liminal position between stars and planets. They are too massive to be classified as planets, but not massive enough to be considered true stars. To put it simply, they're objects that seem like they should be stars, but they just don't quite make the cut. In the past, we thought of brown dwarfs as being relatively dull, insignificant objects, neither providing light nor possessing the characteristics of fully fledged stars. But as the JWST has shown us, these failed stars aren't quite so dull after all. While brown dwarfs are not massive enough to begin the process of nuclear fusion in their cores, they still manage to emit light, just not in the way that regular stars like our Sun do. These objects are too small to start the hydrogen-to-helium fusion that powers true stars, which means they can't shine in the visible spectrum like the Sun. Without that energy-producing fusion process, you wouldn't expect to see them glowing in the night sky. But the James Webb Space Telescope's ability to detect infrared light has revealed that these brown dwarfs emit a faint, subtle glow in the infrared part of the spectrum. This glow is not visible to the naked eye, but it's there, and it's far more intriguing than scientists first realized. Brown dwarfs are formed much like regular stars, by the collapse of gas and dust in space. However, unlike stars, they don't acquire enough mass to generate the internal temperatures and pressures needed for the sustained fusion of hydrogen into helium. Instead, brown dwarfs have a short-lived phase in their development where they can fuse a heavier isotope of hydrogen known as deuterium. Deuterium fusion requires far less energy than hydrogen fusion, so it can occur at much lower temperatures and pressures. However, this process doesn't last long, and once the deuterium is exhausted, the brown dwarf enters a phase where it no longer produces any significant energy internally. From there, it begins a gradual cooling process that can continue for billions of years. Despite this cooling, brown dwarfs still emit a faint infrared glow for much longer than scientists initially expected. This glow comes from the residual heat left over from their formation. Over time, the brown dwarf radiates this heat into space, causing it to shine very dimly in the infrared spectrum. This subtle glow is just one of the many ways in which brown dwarfs are unlike anything we've seen before. They challenge our understanding of what stars are, what they do, and how they evolve over time. The JWST's ability to detect this faint infrared light has opened up a new frontier for astronomers, allowing them to study brown dwarfs in far greater detail than ever before. In fact, the JWST has already made some remarkable discoveries regarding these objects. One of the most intriguing findings is the detection of an aurora around a brown dwarf located more than 40 light-years away from Earth, known as W1935. This discovery is incredibly significant because auroras are typically associated with planets or stars with strong magnetic fields, like Earth's northern and southern lights. The presence of an aurora around a brown dwarf suggests that these objects may have more in common with full-fledged stars than we initially thought. At first, scientists speculated that the aurora might be caused by light emitted from nearby stars, shining on the brown dwarf. However, when they analyzed the data from the JWST more closely, they found something unexpected: methane emissions on the surface of W1935. These methane emissions could be responsible for creating the aurora, which might be produced when charged particles interact with the brown dwarf's magnetic field. This process is very similar to how auroras are created on Earth, where particles from the sun's solar wind interact with Earth's magnetosphere. The methane emissions detected by the JWST suggest that W1935 might be experiencing some sort of atmospheric interaction with charged particles that's heating up its atmosphere, triggering the aurora. The presence of methane is just one clue in a series of ongoing discoveries about brown dwarfs. It raises new questions about their internal processes and how their atmospheres behave under the influence of external forces. This discovery highlights the fact that we're still only scratching the surface of our understanding of these objects. But the mystery doesn't stop there. Another hypothesis regarding the source of the aurora is that it might be caused by interstellar plasma, charged particles from space that collide with the brown dwarf. While interstellar plasma doesn't contain as many particles as the solar wind from stars, its particle density might still be sufficient to create a noticeable aurora around the brown dwarf. If the brown dwarf happens to pass through a region of space with a higher concentration of plasma, this could explain the unusual glow that surrounds it. In yet another twist, it's also possible that the brown dwarf may not be alone. It might be interacting with another object nearby, perhaps a moon or a planet, which could be contributing to the aurora and the unusual emissions detected by the JWST. If this is the case, we could be dealing with a whole new class of objects in space, objects that are neither purely stars nor planets but something else entirely. These discoveries raise even more profound questions about the nature of the universe itself. Brown dwarfs have always been thought of as failed stars, objects that didn't have enough mass to ignite fusion and create the bright light we associate with stars. But now, thanks to the James Webb Space Telescope, we're seeing that these objects are far more complex than we ever realized. Brown dwarfs might just be a gateway to a new understanding of how stars, planets, and other celestial bodies evolve over time. What makes brown dwarfs even more fascinating is the realization that they are incredibly common in the universe. In fact, astronomers now believe that brown dwarfs make up a significant portion of the stellar population in the Milky Way. They are more common than previously thought, especially when compared to the more familiar stars like our Sun. These objects are everywhere, and yet they've remained largely invisible to us until now. The fact that we're only now beginning to understand the true nature of brown dwarfs suggests that there may be many more cosmic secrets lurking in the dark corners of the universe, waiting to be uncovered. But brown dwarfs are just one example of the mysterious objects that populate the universe. The discovery of their faint glow and their possible auroras has led to an even bigger question: could there be an entire dark universe, full of invisible or barely detectable objects, right alongside the visible one that we know so well? We're familiar with the visible universe, the one that includes the stars, galaxies, and planets that we can see with our eyes or with telescopes. But what if there's a vast and largely hidden universe, composed of dark matter, dark energy, and objects like brown dwarfs that we're just starting to uncover? The idea of a dark universe is not as far-fetched as it might sound. In fact, dark matter and dark energy are some of the most important components of the universe, even though we can't directly observe them. Scientists know that these mysterious substances exist because of their gravitational effects on visible matter. Dark matter is thought to make up a large portion of the mass in the universe, while dark energy is believed to be responsible for the accelerated expansion of the cosmos. But despite knowing that these substances exist, we still have very little understanding of what they are or how they work. In addition to dark matter and dark energy, there are other types of dark objects that scientists are just beginning to discover. Black holes, for example, are another type of cosmic object that we can't directly observe, but we know they exist because of their gravitational influence on nearby matter. Just like dark matter and dark energy, black holes are a crucial part of the cosmic puzzle, and they play a significant role in shaping the evolution of the universe. But what if there's more to this dark universe than just dark matter, dark energy, and black holes? What if there are entire classes of objects, like brown dwarfs, that exist in a realm of darkness, emitting light in forms that we can't yet perceive. These objects might be right in front of us, hidden in plain sight, waiting for the right technology to reveal their true nature. This idea is supported by theories like string theory, which proposes the existence of multiple dimensions beyond the familiar three-dimensional world we live in. String theory suggests that there could be countless hidden universes or aspects that are right next to ours, but we can't see them because they exist in different dimensions. Could it be that some of these hidden universes contain objects that emit light or energy in ways that are completely invisible to us? If so, then the dark universe may not be dark at all. It may simply be a universe that operates on a different wavelength, one that we haven't yet discovered. As we continue to explore the cosmos with tools like the James Webb Space Telescope, we're likely to uncover even more mysteries about the nature of the universe, the stars, and the objects that inhabit the vast expanse of space. The discovery of brown dwarfs' infrared glow is just the beginning. There are surely many more secrets waiting to be uncovered in the dark corners of the universe, and with each new discovery, we get closer to understanding not just the universe around us, but the very fabric of reality itself. As we peer deeper into space, we may come to realize that our understanding of the universe is just the tip of the iceberg. The more we learn, the more we realize that there's so much we don't know, and the more we understand that the universe is a far more complex, mysterious, and wondrous place than we could ever have imagined. What other secrets lie hidden in the darkness, waiting for the right instruments, and the right minds, to discover them? Only time will tell, but one thing is certain: the journey to unravel the mysteries of the universe is only just beginning.